Okay, good morning. Let's get started. These are our last two class sessions. So the objective today is just to do the final exam review. And I will be specifically pulling from the problems that are on Blackboard. Under Blackboard is under course content. And if you scroll down all the way, it's the final exam review for solutions. So there's an exam and the solutions are there too. And since the solutions are there, if you have any problems on any of the chapters, then, the solutions are there, but I'll go over some specific ones today. Your final exam is on Tuesday, May 5th from 9:30 to, 11:50. You must log into Zoom, and immediately after the exam is over, you should upload your work to Blackboard. The last exam, the last test on factoring quadratic equations is going to be available today, and it will end on Saturday. So you will have, at least Sunday, Monday to just really focus on the final exam. And the final grades will be posted on Friday, May 8th. And that's when you can probably log into our link and look at your academic profile evaluation. As you finish your last exam, I will be updating those grades in Blackboard as well. All right, any questions? The summer and fall sessions are available for registration. So, we talked about the next math class. If you want to go and register for the summer or the fall, the classes are posted and available. So any questions here? All right, so I am ready to go to Blackboard. And I'm going to pull up, okay, so here I go again. Okay, so this is number 2 from the final exam review posted on Blackboard. And if you look at number 2, the direction says to evaluate. So all you're going to do is evaluate. It tells you that the value x equals -3 and y equals 2. So basically, this is a substitution. You're just going to substitute x for a -3 and y for 2. But one of the things that this exam wants to make sure that you know as part of your learning principle, your core learning objective is this negative sign here. This negative sign is what the skills that we want to make sure, because here this is a negative sign and x is also -3. So you want to be very careful when you are substituting. You want to substitute the formula, so we have a negative in the formula, and then x is -3 squared. So you want to make sure you put those in parentheses. This is y, and then y is 2. And I'm going to keep on putting that in parentheses so you'll clearly know that that's multiplication. And then this is +3, and x again is -3. So all I'm doing is substituting the variable. Wherever I see x, I put -3. Wherever you see y, you put 2. And then your denominator, you have 4y, which is 4 times 2. And I think that as a student, particularly on the final exam, as we try to assess all of your skills that you've learned this semester, if you just kind of take a moment to substitute, I think that'll be good. Some students are going to say, oh, I know 4 times 2 is 8, and they'll just put the 8 there, which is fine. Again, I just kind of caution you to take your time on Tuesday to make sure you go, because the final exam is worth 20% of your grade. So you want to make sure that you are as accurate as possible. So if we evaluate this, we have a -3 squared is 9. So that's still going to be a -9 there. And that's times 2. And I'll just go on and take the extra step. And then you have 3 times -3. That's a -9. And this is divided by 8. Again, all we're doing is simplifying. This is basic. You have your calculator. This is -18 minus 9 divided by 8. So that's becomes -27 divided by 8. And I think that you can leave the answer like that. You don't have to work it out into mixed number or anything like that. You can just, questions here? Any questions?
No.
Okay, no questions. So I think that what I'm going to do is that I'm going to go straight to the application problems. Let me clear this. I'm gonna go straight to the applications problems because I think someone talked about the application problem. So the application problems, the one that, let's just scroll down here. The factoring is definitely going to be on there, so you definitely want to make sure you review those. Graphing is going to be on there. You have to do some graphing. That's definitely going to be on those. And I'm going straight to the application problems because they were asked. Okay, so let's look at number 62. Let's look at number 62. Number 62 is the sum of consecutive integers. And consecutive integers, you really want to make sure you understand this one. And you know, I'm not, okay, so let's look. The sum of 2 consecutive mile markers on I-95 Maryland is 93. Find the numbers of the mile markers. So the one thing you want to look at is the sum of 2 consecutive mile markers. So that means that the sum of 2 consecutive integers, and we have to make sure that we can demonstrate that algebraically. So I'm going to see if I can, it's going to take me, I can't work it in this little space right here. So I'm going to see if I can put this on the whiteboard. So let me see how I can do that. Okay, so this is number 60 in a new share. Okay, so this is number 62. Can you see the sum of 2 consecutive integers?
Yes.
Okay. So let's see how we do it. Okay, the sum of 2 consecutive integers. What you want to do is that you want to make sure that you can articulate what 2 consecutive integers are. So the sum of 2 consecutive mile markers, 2 consecutive integers. The first thing you want to make sure that you can say that X is the first consecutive integer, and the second consecutive integer is X plus 1. Right, so you want to be able, that's from a student perspective, you want to make sure you can articulate that. All right, and it says the sum of 2 consecutive integers is 93. And since you're talking about the sum, now you can really put your equation together because this is X plus 1 equals 93. Those are your 2 consecutive integers. Right, so now from here, it's just a matter of just solving the equation. This right here, from here, this is a basic linear equation. And hopefully this is a skill that everybody has got. Hopefully there's no one on the call that's really struggling with this at the end of the semester, because this becomes 2x plus 1 equals 93. And you have 2x equals 92. All right, I'm hoping I can skip a step here, subtracting 1 from both sides. And then 92 divided by 2, you have x equals 46. So 46 just represents the first mile marker. So we'll say this is the first mile marker. And then if we look back at how we started the equation, we have x plus 1. So the second mile marker,
Dr. Ted, you get the second line is 2x equals 92.
Yeah, 2x equals 92 because I subtracted 1 from both sides.
Oh, okay, okay.
Mm-hmm. And so then we have x plus 1 equals 47, which is the second mile marker. And then if you can check it, you know, one of the things is that when you're working with the word problems, you want to kind of look at it and make sure that they're logical. So, you know, you have read your problem, 2 consecutive mile markers is on Maryland is 93. Find the numbers on the mile markers. So if you add 46 plus 47, that equals 93. So that kind of is like a brief check for you. Okay, any questions here? Any questions? Okay, so let's look at number 66, which is another application problem. And it's a basic problem that talks about the average and how you find the average. And the one thing about the average is that, you know, you should add up all the numbers and divide by, you know, the number of items in the group. So we should make sure that we really understand the average. This is just a problem that they like to use. I'm not sure if it's really on the exam, but I know this is one that they like to put on the exam. John has a test score 68, 56, and 74 in his first 3 exams. It says, what are the possible scores he can make on the 4th test in order to make his grade at least a letter grade of C after the 4th test? So you're talking about at least C. So at least, so that means that that's an inequality. At least, you want to make sure that you can handle that at least. So at least. So at least is greater than or equal to. So you want to make sure you can handle that. So if we look at our first 3, our first 3 scores here, he has what is 68. So to get the average, all you're going to do is add them up and divide by the number. So the average here, you have 68 plus 56. These are his scores, plus 74. But what you need as a student, you know, it asks you what are the possible scores he can make on the 4th exam. So you need to make sure that you add an X in there for the variable. And this is going to be all divided by 4. And the reason why it's divided by 4 is because you have 4 exams. Excuse me, it says at least a grade of C. So at least that means it's greater than or equal to, that means at least a grade of 70. So that means that 70 is the smallest number that the student wants to make because he wants to make at least a C at the course. Excuse me. All right, so again, now this is like a basic linear equation here. Now, inequality here, you should be able to handle this one now that you've got it set it up. You have to add 68 and 56 and 74. And that's 198. So I'm going to write real small here. So this is 198 plus X divided by 4 is greater than or equal to 70. And one of the things that we talked about equation with fractions. And when you start handling equation with fractions, you want to make, one way you can do this, I think is very easy, is just going multiply by that 4. You know, we talked about multiplying by the least common denominator 4. And then once we multiply by 4, we'll have 198 plus X is greater than or equal to 280 because you're multiplying 70 times 4. And then it's a basic linear equation. So I'm going to take this up here. 198 plus X is greater than or equal to 280. And then you're going to subtract 198 from both sides. So the X is going to have to be greater than or equal to 82. So the student has at least to make an 82%. at least a 82% on the fourth exam. All right. Any questions here? You guys are awfully quiet today. Is this going to be a session where I'm just going to go in and just be working the problems that I think I need to do? Student says, yeah. Okay, so let's look at 67 and 68 here. New share. Okay, can you see 67 and 68 there?
Yes.
Okay, good. All right, so let's just look at both of them. And I think that these are some practical problems for you to practice on. And the main thing that I want you to understand or to realize when you start working on these practice or working on these application problems, you have to make sure that you're able to identify the expressions that relate to the problem. So we look at 67. So you have a length of a rectangle. Sine is 3 feet more than its width. If the sine's area is 54 square feet, find the length and the width. So when we're looking at 67, the first thing you have to know is that let's draw a picture, because sometimes a picture is important for number 67. And also, the other thing that you want to do is that you have to make sure that it says that the length and the width, it says find the sine's area. So you have to know the area. This is what you have to know, is that the length times the width equal the area. The area of a rectangle is the length times the width. This is something that your core learning principles, I hope you got that. All right, so let's look at a picture here. So let's look at a picture here. It says you have a rectangular sign. So let's just draw a rectangular here. You have a rectangle sign. Is the length. So we have the length here is 3 feet longer than its width. 3 feet longer than its width. So this would be maybe 3 feet longer than its width. So we can say that this is your W plus 3, because this is your length. This is your length here. It's 3 feet longer than its width. So the important thing that you have to do, make sure that you do as a student, is that you have an algebraic expression that represents the length and the width. So the length here is W plus 3, and the width we'll just use as the variable W. All right, and we know that the area is 54. So we have the length times the width, and you have the area is 54. So let's just plug it in. So the length we say is W plus 3, and the width is W. And when we multiply those two together, that's going to equal 54. Any questions here?
So when it asks for the area, the formula would be length times width equals area?
Yes, the area of a rectangle, right? The formula is length times the width. That's correct. And that's what you want to know as a student. That's not going to be on the test. You're just going to get the problem here. So let's see. So if we look at this, if we multiply this out, we're going to have W squared plus 3W equals 54. And one thing that you might want to look at here is because you have a quadratic. So how do you handle this quadratic? This is almost like if you had this as a quadratic form, what do you have to do first here? I'm waiting on the answer from you guys. We have 12 students here. How many students do I have here? We have 10. All right, so how are you going to solve this? What's your first step? You have a quadratic.
0.
Very good. You have to put it in standard form for it to equal 0. So this becomes W squared plus 3W minus 54 equals 0. Very good. This is what we just got through doing, solving the quadratic. And how are you going to solve this quadratic equation? How are you going to solve a quadratic equation?
You factor it out.
Right, factor it out. Very good. All right, so we're getting there. Thank you for the feedback. So I won't make sure that I'm here by myself. So you got to factor it out. So we're going to do, we know this first term is W, the second term is W. So now your objective is to think of two numbers where you have the product is negative 54 and the sum is the middle term, which is 3. Okay, so you're on. What two numbers you're going to multiply together to get negative 54, but you're going to add the same two numbers together to get 3.
-9 and 6.
Okay, negative 9 and 6. Let's check it out. You multiply them together to get negative 54. That's right. You add them together to get 3. Okay, very good. So your critical integers becomes W minus 9, W plus 6. Right, so again, now this becomes with the zero principal factor here. When you have this right here, where you have two numbers where both of them, you have two factors and they multiply to equal 0, you know that W minus 9 is going to equal 0, or W plus 6 is going to equal 0.
Professor,
Uh-huh.
-9 plus 6 equals -3.
Okay, bingo. Very good. Very good. So what do we have to do here?
Switch the additional signs of
Switch the sign. Very good. Thank you. So we need to switch the signs here. So this should be 9 and negative 6. And 6. So that means that X plus 9 is, and this should be X minus 6. So X plus 9 is 0 and X minus 6 should use it. Okay, thank you. I love when students make thinking happen by catching a few little mistakes. That's very good. All right, so you have that. So now let's stop. So either W equals -9 or W equals 6. Okay, so what are we gonna conclude from here? Which one? What do you think about those solutions? How are we gonna move from here?
-9.
W equals 6.
Right, -9, this is erroneous. That's very good because, you know, length can never be negative. You're trying to find the length of a rectangle. Always kind of draw back in what you're trying to do to length. So -9 is erroneous because your width is never going to be negative. So your width
Would be 6.
is going to equal 6 feet because those are the units. So what's your length going to be? If we go back up here and see what we said the length was here, it's W plus 6, W plus 3. I'm sorry. Eraser. W plus 3.
It would be 9 feet.
Yes. Equal 9 feet. So you have your width equals 6 feet and your length equals 9 feet. And again now, once you get these solutions, kind of take a moment and kind of make sure you can go back and see if they are accurate, because you have the length times the width equals 53, and you know that 6 times 9 equals 54, I'm sorry. So it kind of checks out to be correct. All right. So you want to kind of go over these, and more importantly, you want to be able to write the algebraic expressions for your length and your width. All right, any questions here? this was a really nice problem because I really like it because it kind of, you have a word problem, very semi-similar, you know, basic in terms of the length and the width of a rectangle, but you have to multiply, and then you end up with a quadratic, and a quadratic is, you know, one of the our last learning objective where you have to factor, you know, bring out the linear equations and then find the solution. So this is a pretty good problem. Any questions? Any questions?
No.
Okay, so let me clear this. I'm gonna clear this. I have been putting the recordings on Blackboard, so even though I clear it, you can go back and look at it. I have to clear it because I've paused and resumed, so I have to always check to make sure that I'm recording here. All right. So, all right, so let's look at 68. I'm gonna draw a picture of it, and then I want somebody to really jump in to kind of help me out here. All right, I'm gonna make this a little bit bigger. So this is gonna be 68. Okay, I'll get you started. I'll get you started by just kind of drawing it out for you. Because the pictures are going to be important. I highly recommend that you do the pictures. So when you upload your work in Blackboard after the final exam, hopefully I'll see some pretty nice little pictures. Here we are again. You have a rectangular field. So, you know, you can just start out with a rectangular field. So you have a rectangular field. Let's draw a little rectangle here. I don't have a ruler, but that's a nice little rectangular field. It's 4 times as long as it is wide. This is where your algebraic expressions are going to come in. You as a student have to make sure that you can articulate this algebraically. A rectangle field is 4 times as long as it is wide. 4 times as long as it is wide. So we'll just say your width is W. 4 times as long is going to be what? 4 times as long.
4x.
4x or 4w. Yes, 4x or 4w. 4 times as long. And that's going to be important. But here, the last one they talked about the area, now they're talking about the perimeter. So again, now this is one of your core learning objectives, some basic geometry that you as a student should know what the perimeter of a rectangle is. And that's, you know, so, you know, perimeters that you're going to add up all the sides around. And some students, you know, if you put 2 times the width plus 2 times the length is the perimeter of a rectangle. And this, again, now you won't be given this. This is one of your core learning principles that you want to know. And what are the dimensions of the field? So from here, you should just be able to substitute the width and the length. And it tells you that the perimeter equals 550 yards. So I'm gonna put this on pause for a moment. And I want you to pause. Okay, I'll help you. I don't know where you are now, but I'll help you with the substitution. The perimeter is 550. And that equals 2 times the width. But we said the length was going to be 4w because it says the length is 2 times as long. So this is going to be 2 times 4w. All right. So okay. And let me just resume solving this again now. From here, this become a basic linear equation. This is gonna be 550, which is the perimeter. This is 2W plus 8W. And it's important that when you start using your algebraic expression that you only use one variable. I use W, somebody use 8 or X, that's fine too. As long as you can clearly distinguish what's the length and the width, this becomes 10W.
You get- Okay.
So your width is gonna be 55 yards. And then in order to get the length, you always want to make sure you go back to your picture. And that's why this picture and this algebraic expression here is really, really important. Because then you have 4W, which is the length, is 4 times 55. And 4 times 55 equals 220 yards. So we have the width here, our final solution. Okay, so this moves up and down with everything. All right, so you have the width that equals 55 yards. And then you have the length that equals 220 yards. And you can always, you know, take a moment. We'll have 2 hours on the exam to just do a little quick check. And we're going to check right back up here into the formula. So you have the perimeter, which is 550 yards. Does that equal 2 times the width, which is 55, plus 2 times the length, and we said that that was 220. So 2 times 55 is 110 plus 440. And we have 550 does equal 550. So it kind of checks out here. All right. So that's one of our, another application problem. These problems are under course content, then scroll all the way down to the bottom and you should see final exam. And again, now the solutions are also posted as well. So I don't know, you want to look at some of the factoring? Has anybody looked at them and you have any particular questions or anything? All right. This is a really nice exercise for me because it kind of lets me know how, you know, in the summer when I teach, you know, one thing that I know I have to do is do something to engage the students because otherwise this will be a session where I'm on Zoom and doing everything, and that's no fun. Okay, let's look at some of these factoring. Let's look at 46. This is kind of what I'm kind of jumping around. I don't have a specific order. Let's look at these 46 factoring, because definitely factoring is for sure going to be on there. Let's look at a few of these. Let's look at 46 for first of all. You see 46 on my screen?
Yes.
Okay. All right, so I won't do every single one of them, but 46 is a good one to start with. All right, so 46, it says the factor. It says the factor. What are you gonna do on 46? It says the factor. No, you have to talk. I'm not gonna do
Greatest
the
common
problem.
factor.
Greatest common factor. Thank you. Very good. You have to give me some feedback. Greatest common factor. Very good. Okay, so here you have to make sure you get the GCF. The greatest common factor, if you look at all 3 terms, is going to be what?
11x.
11x.
11x, very good. So on 46, when you factor out the greatest common factor, remember, sometimes you can kind of look at it like dividing out. Students have, when you have the greatest common factor, so we're going to take 11x. And when you take 11x, kind of divide, and if you want to think about it, you can kind of look at, you divide that by 11x. When you divide it by 11x, you're going to have 5x to the 4th power. And some students, I've heard students that say they think about dividing it by 11x. And you can kind of think about that if you want to. The middle term is going to be what?
11x to the 3rd. Well, 11x cubed.
Right, very good. And you again dividing this by 11x, and the 3rd term is going to be what?
2
Right,
plus 2.
plus 2. All right, so that's it. Factoring out the greatest common factor. And because this is exponent is 4, you don't have to worry about trying to factor it out any further. All right, so maybe we can hop down to number 48. Let's look at 48. Again, you're factoring out the, it says the factor. That's the direction says factor completely. The first thing you have to do is look for the greatest common factor. So what's the greatest common factor in 48?
7x.
7x, right, 7x is definitely a greatest common factor. But for me, because I'm looking at this negative sign here, let's factor out a negative 7x as the greatest common factor. All right, again, like I said, some students look at it like a division, and I think that's okay because it's like you're dividing out the greatest common factor, which is a good objective. So the greatest common factor, if we divide out a negative 7x, and again, look at it like you're dividing out negative 7x here, negative 7x, negative 7x. You can think about it like that, I would say. So your first term is going to be what?
6x to the 4th.
Very good. On the second term is going to be
Positive 2x squared.
all right. In the third term,
Negative 3.
X. -3.
negative 3. Very good. All right. It says the factor. You want to make sure that you handle that. All right. That's pretty good. Let's look at okay, you got a few factor by groupings there. I'm going to let you guys kind of go over those. Let me see. Any questions here? Okay, so let me go up here, edit totaling. There it is. Okay, so let's go down here, factoring. Let's look at question.
Dr. T, when it says factor completely, you always find the G.
Great, right. That's always your first question that you want to ask yourself. What's the greatest common factor?
And then you factor it out. Okay.
And you factor it out from there, right? That's always your greatest common factor. Okay, so let's look at 54. Let's look at 54. Okay, we can look at 53 and 54. Okay, because both of those, and the reason why I want to look at both of those, 53 and 54, is because neither one of them have a greatest common factor. So if you look at 53, 12, 17, and 6, there's no common factors there. And if you look at 54, 3, 20, and 7, there's no common factors in all 3 terms. So let's look at these 2 problems where the greatest common factor is where no terms have a greatest common factor. And one of the things that we said when they don't have a greatest common factor is that you still have to do the same thing, and that is looking for the product and the sum. But the product and the sum is going to be very different of how you, not very different, but you have to multiply 2 terms to get the greatest common factor. So if you look at number 53, all right, and you still have to look at the product and the sum. So what's the product? When you look here, you have to multiply your A times C. So your product here is going to be 12 times 6. And 12 times 6 is going to be 72. And then your sum is always going to be the middle term, which is negative 17. All right. So I'm going to give you a moment. As students, that's going to be your assignment. What two numbers that you multiply together, you get positive 72. But when you add the same two numbers together, you get negative 17. And we
Neg-
talked about
9 and 8.
Yeah.
Positive 9, negative 8.
it's going to be what? What'd you say? Somebody said something, I just didn't capture it.
She said -9 and -8.
Negative 9, negative 8. So let's check it out. You multiply negative 9 times negative 8 is positive 72. That's right. When we add them together, you get negative 17. So if I check it, these right here are right. These become your critical integers. So here, the one thing I want to caution you, you don't want to just kind of jump into here because you have to multiply your A times your C. You kind of have to trigger that. Now you have to do an extra step. And this extra step is going to be what? Remember the extra step?
Accurate.
What's the extra step you have to do here when you have to multiply A times C?
You gotta factor it out.
Factor out, you have to rewrite the middle term.
Right. That's not right. Yeah.
Okay, you have to rewrite. So remember,
Middle term.
rewrite the middle term. So remember, whenever you have to multiply A times C, you have to rewrite the middle term. And when you rewrite the middle term, this is where we're going to start factor by grouping.
Right.
All right. So let's rewrite the middle term. We have 12x squared. Using these critical integers, we have minus 9x minus 8x plus 6. Direction says the factor. And so, okay, let's do it. You got 4 terms. What do these two terms have in common?
3x.
3x. And when you factor out of 3x, you're going to have what?
4x.
4x minus
Minus
3.
3. Very good. And so when you look at these, what do these two terms have in common?
2.
-2.
-2.
You can either one. If you factor out a -2, so if you factor out a -2, what are you going to have here?
4x
4x
-3.
minus 3. All right. So when you're factoring these out, it's when you factor by grouping. I think someone told me in a study session that I had, these right here are always going to be the same. You always have to have those factors are always going to be the same. All right. So let's go. So what they have in common here is 4x minus 3. And the second term is going to be what?
3x minus 2.
3x minus 2. Very good. So that's your final solution here. And let's go and check it. Let me show you how you check it. Remember how we checked it very quickly? That's 4x minus 3 times 3x minus 2. So let's check it to make sure we come up with our original polynomial here. And when I check it very quickly, I just multiply the first two terms is 12x squared. Okay, 12x squared, boom, got the first term. The second term or the last term, I multiply these last two, -3 and -2, multiplying them, let's get a +6. Okay, boom, got that one. So the middle term is always what's important. The middle term is very important. The middle term is what you always want to check. And in order to check the middle term, We're checking the middle term here. The middle term is what we're checking. When you check the middle term, you take the two inside terms, multiplying them is negative 9x. Checking the middle term and the two outside terms, you're multiplying them. That's negative 8x. And negative 8x plus negative 9x is negative 17x. And that's how you can check your middle term. All right, so this is like a quick check part over here. This is how I check it. And you can almost like just kind of check it in your head. But this is your final solution here. Any questions here? Any questions? All right, so let's look at 54 here. Let's look at number 54. Let's look at 54. And again, now, one of the things that we talked about, we also talk about guess and check. You know, that's the term here. We can go through the you know, what we did here, multiply your sum and your product, but we can also guess and check, because now that we know how to check, we can kind of guess and check to see if we can come up with, this is another method you can use, guess and check. So let's guess and check on this 54. So let's do a guess and check. Guess and check. Okay, so we have, let's do this. We have 3a squared minus 20a minus 7. Let's guess and check. All right, and the reason why this is a good candidate for guess and check is because this number right here and this number right, 3a, 3 and 7 are prime numbers. Because they're prime numbers, you know, we don't have too many ways to go. All you can do is 3 and 7, so you don't have too many ways to go. And then we can just check it by our little method up here. All right. So this 3a, this is the only way you're going to have those first two terms. There's no other way you can have them, because there's no other way that you can get 3a but 3. I mean, you know, you don't have any other factors of a. So those are standard. And now, because this is a prime number, all we have to do is just work around with the 7. So let's work around with the 7. So maybe we'll put a 7 here and a 1 here. And we can play around with the signs. And because we're guessing and checking, all we're doing is guessing and checking. If it doesn't, then we just change it. All right, so let's check this out. Let's check it. When you multiply the first two terms, 3a times a, 3a squared. That's a bummer. That's good. All right, so now we got 7 and 1. That's okay, that's 7. So let's check the middle term. Is there any way we can multiply these numbers to get the middle term? If we multiply these two middle terms, this becomes 7a. And you multiply your two outside terms, this becomes 3a. Okay, so there's no way we can add those numbers up, even if we change the signs to get 20. So that's not going to work. Again, we're guessing and checking. So since we're guessing and checking, let's change the 7 and the 1, because the 3 and the a are standard. There's no way we're going to do the 3 and the a. Again, we're guessing and checking. So now, let's put the 7 here. And let's put the 1 here. Guess and check. So we know the first and the middle term, we're going to multiply these two together. We get 1a. And we're going to multiply these two together. We get 21a. Okay, so this looks better because there's a way we can get 20. So what does these signs have to be to get a negative 20 and a negative 7? So one's got to be negative, one's got to be positive. Help me with the signs.
Yes.
What should the signs be? Are y'all with me?
-1.
Okay, so this is -1 and a positive 7 here. So let's check it out. This becomes a -a and a positive 20. But check it out, Curtis, this middle term has to be a negative 20. But this here, so what do we have to do to the signs? Remember, we're guessing and checking.
Right.
All right.
So the 21 has to be negative.
Right. The 21 has to be negative. So that means that this 21 has to be negative, and this has to be positive. Again, we're checking the middle term. So when we multiply here, this should be +1 and -7. -7. So here, so the middle term is +1, and this right here is -21, and that's the middle term. And again, just kind of take it a moment and just check it out again. We multiply the first two terms again. So if we come up here again, now this is guess and check. And the reason why I chose this as guess and check is because the A term and the C term were prime numbers. And I knew that we would have a better chance with that, because when it's not a prime number, then you have more factors to deal with. All right, so this is our final solution here. Now we're just gonna go back and check it. Our first two terms, 3A times A is 3A squared. Boom, got that term. +1 plus times -7 is -7. Boom, that term is correct. The middle term is for the students where you have to be very cautious with. Again, we're taking the first two terms. This is 1A. The second two terms, we're multiplying those. This is -21A. And you add those together and you get -20A, and that checks as well. So now you know that that's your final solution. So if you look at these two, you can kind of, just kind of depend on your comfortability level as you continue to practice to see which one you like better. You can go through the product and the sum and think of two numbers that you multiply together, get 20, and then, rewrite the middle term, and then factor this out. And then at the end, you always want to check. But, if you're really comfortable with going through the process, that's okay, and check. And the reason why they guess and check here is because you have 12. There's a lot of factors of 12. You got, 2 and 6, 1 and 12, 3 and 4, and then 6, you got 1 and 6, 2 and 3. So there's a lot of factors here when you start guessing and checking, because you can move these around a lot. But when I looked at that, this is a prime candidate for guess and check because they're prime numbers. All right, so any questions here on factoring? Any questions?
No.
Okay, so while we're here, let's look at some more fact. Oh, okay, I still have to clear it. All right, so let me clear this. And scroll down to 55. These are good. All right, again now, remember, let's look at these 55, 56, and 57. These are pretty nice because the reason why they're nice is because you can look at because these come with our special factorization. It looks at your factoring. All right, so 55, what do you notice about 55? Do you notice anything?
Yeah, the squares.
Right, it's a square, it's very good. So this is the same thing as x squared minus 4 squared.
8 squared.
Right, and when you can do, 8 squared. Right?
8 squared.
8 squared, sorry. Okay, and when you see perfect squares, you know that automatically factors to what?
X minus 8 and X plus 8.
Right, very good. X plus 8, X minus 8, very good. All right, very good. And then if you want to, you can take a moment to check this out because your middle term right here is positive 8x and your outer term is negative 8x and they cancel. So you can still kind of do your check here as well. All right, these are your special factorizations. So when you get to the exam, you want to make sure that you recognize your special factors. All right, so let's look at this one. What are the squares here? Anybody?
3 and 2.
Right, this is 3x squared minus 2 squared. And when you have a perfect square, and make sure that this is a minus, because sometimes they'll put this as a plus. And if it's a plus, that's not going to work. It's only when it's negative, then you factor this out. This becomes the factors of 3x minus 2 times 3x plus 2. All right, now you can do the check in your head real quick. So again, this is something that's in your toolbox that you know the factors. These are perfect squares. This is 10y squared minus x squared. And again, when you have this is subtraction here, it must be subtraction, and you have two perfect squares. They fit the pattern in the special factorization. This is going to become 10y minus x. Oh, no. 10y minus x times 10y plus x. All right, so that's part in your toolbox. You want to make sure that you can remember your special products there. Let's scroll down here. Okay, so would you repeat the question, please?
Oh, God. All the original equations, they're the same.
They have a negative, right?
Yeah, but the second term, yeah, it's the answer ended up being 3x minus 2 and 3x plus 2.
Okay, all right, so let's look at the pattern. Okay, this becomes in the special factorization and it also becomes a part of the pattern. So the pattern, when we look at this all of them has to have a negative sign. That's right, a negative here, and a negative here. And when you look at the special products, this is 3x squared. I'm looking at 59. And then this is minus 2x squared. And they have to be a minus. So the pattern that we have is that 3x minus 2 times 3x plus 2. So when you factor out, these signs has to be opposite. And the reason why these signs has to be opposite is because there's no middle term here. There's no middle term here. So let's just do the long way and let's check this one out. Let's do the long way and let's check this out. We're just going to check this out. We have 3x minus 2 times 3x plus 2. And I said that when all else fails, you can always just do the distributive property to check. That's something you have and it never leaves you. Let's just do the distributive property. 3x times 3x is going to be 9x squared. Any questions?
Okay. All right.
And when you have 3x times 2, this right here is going to be plus 6x. You agree?
Yes.
And you're going to multiply negative 2 times 3 is minus 6x. You multiply it, you agree?
Yes.
The negative 2 times negative 2 is negative 4. And the reason why these, when you factor, have to be opposite, because these right here, we want to make sure that they are gone, because when we check it, this factor right here doesn't have a middle term. So this becomes 9x squared minus 4. So that means that when they're negative, you see this is 8x plus 8x minus 8 because there's no middle term here.
Okay.
Y minus, so when you have perfect squares with a minus sign, when you factor it out, One has to be positive, one has to be negative because you don't want a middle term.
Okay, okay, all right,
All right?
okay.
Okay, any other questions?
How many problems on the test?
20. 20 problems on the final exam.
Professor?
Yes.
I was doing the review test yesterday, and this is still in the factoring category. It was a problem, and I have no idea how it even got to. It was like a multiple question answer, but I have no idea how it even got to that. Would I be
Okay,
able to see the
do you
problem?
remember what the problem was?
Yeah.
Okay, so let me clear this board right here. Let me clear this. You're gonna yell the problem out to me?
Yes.
Okay, hold on. Let me get a whiteboard here. New share, whiteboard. This is nice. Okay, so what's the problem?
8x squared plus 24x minus 144. And it said factor completely.
Okay, can you see that I changed the pen to can y'all see that?
Yes.
Okay, all right. So it says factor completely. This is a pretty nice problem. So what did you do first?
I first multiplied 144 and 8 for the
Okay,
product.
that's a good start. But what can you do before that? What is what you want to think about when you're factoring completely? What's the question that you're asking yourself?
What's the greatest common factor?
What's the greatest common factor? Okay, so
Oh, I
what's the
see.
greatest common factor here? That I think that
Is it 8?
right. Greatest common factor is 8. So when we factor out an 8, what are we going to have here?
X squared,
Plus
8 times 0 to give us 24.
8 times 24. Do you you asking me the question?
3x.
3x minus. So when you take 144, 8 divided by 144 is going to be
18.
18. Does it look better now?
Yeah.
Yeah, because now, so when it gets real complicated, I always go back to the greatest common factor. So here, can we factor this further? Remember, sometimes it may be prime. Do we know two numbers where we equal the product is negative 18 and the sum is 3? Are there two numbers you multiply together, get negative 18, and the sum is 3? And the way I do it is I just look at the factors.
It's a negative 6 and 3.
Let's see, negative 6 and 3. So
No, 6 and 3. 6 and 3.
okay, let's look at 6 and 3. So you multiply 6 times 3. So what about the sign? Something has to happen.
I'm sorry. It is a negative 6.
Huh?
I'm looking at it, trying to make sure that the 3 is positive. So it's a negative 3.
Negative 3, very good. So negative 3 and positive 6. So
Right.
you multiply them together, you get negative 18, you add them together, you get positive 3. So these right here are your critical integers. So this becomes x plus 6 times x minus 3. And then you can always just kind of mentally check in your head, again, checking your middle term to make sure that it is taking a middle term just to make sure that it's correct. All right, very good. Any other questions that you found out that you couldn't handle or thought you couldn't handle?
These problems you do both, you find the greatest common factor and then the product and the sum.
Right, exactly. And always, whenever it says factor, the first question, even if they don't have any common factors, the first question that you want to make sure that you ask yourself is, what are the common factors? That's going to be always your question. What are the greatest common factors? That's your powerful question when you start factoring here.
Professor,
Yes,
can we look at 35 through 38?
35 to 38. Let's look at 35. So what's 35 to 38? Let me get back here. This year. 35 to 38. Let's look what's 35 to 38. Okay, okay, these are pretty nice problems. Let's look at these. Yeah, 35 to 38, 35. Okay, these are inequalities. That's fine because you have to graph. You're gonna have to graph the solution. And I don't know how we're gonna do the here. So I don't think that they're gonna ask you to. Yeah, so this is good. Okay, so let's graph these 35 to 38. 35 to 37, did you say? Once you do 3 of them, then you got enough here. All right, so let's look at 35. It's just an inequality. What's the first step here? Then you're just gonna, you remember now, when you're doing these inequalities, you wanna make sure that you can handle them just like regular equations. You can solve this inequality. You can solve the inequality like an equal sign. So the first thing you want to do is you want to make sure you can handle the distributive property. Is it green okay where you're looking?
Yes.
Okay, so you want to handle like a distributive property here. So you have 4x minus 12 is greater than 20. You should be able to handle the distributive property here. And then we're going to add 12 to both sides. So you have 4x is greater than 32. We divide both by 4. So we have x is greater than 8. Okay, so that is the solution. So, and it's gonna, you have to figure out, you know, technologically how you graph it. So when you graph this, if we have a graph, and so we have x is greater than 8. So let's look at the graph here. And so one thing you want to point out is the endpoint here. So the endpoint here is, you know, we'll say this is 0, this is 2, 4, 6, 8. We'll say this is 8 right here. And so the endpoint is going to look like this parentheses, and it's x is greater than 8. So it's going to be everything that's greater than 8 is going to be here. So this is your graph. This is the solution. This is the graph. What about the interval notation? What's the interval notation here? Your left endpoint is going to be what? And your interval notation, what's this left endpoint going to be? Y'all still, can y'all hear me?
Yeah, we can hear you.
Oh, okay. Okay. So what's this left endpoint here? Interval notation, you forgot interval notation?
It's not 0, is it?
No, it's not 0. So remember, this right here is going to equal this. Your left endpoint here is going to be 8.
Okay.
And then your right endpoint is going to be what? Infinity, because you know this goes from negative infinity to infinity. You remember that?
Yeah.
Oh, you do? All right.
Remember now.
You remember it now? Okay, good. All right, any questions? I'm going to clear this so I can have a lot more writing space here. Any questions?
No.
Yeah, I wish I could give this pencil to somebody else. We'll practice that in my next class. Let's look at the second one here. Negative x minus 7 is less than or equal to negative 5. So I just went on, did the distributive property here. And then again, you're going to solve this like a regular equation on 36. So you have negative x is less than or equal to 2 because we're adding 7 to both sides. And remember now, the only thing that you have to do different here is that when you multiply or divide by a negative number, remember the directions of the inequality changes. When you multiply or divide by -1, because your variable always has to be positive. So this is going to be x is greater than or equal to -2. X is greater than or equal to, and remember you have this equal sign here. This is greater than or equal to, so that means that -2 is included in your solution set. So when we graph this, because remember now, the solution, the graph, and the this is negative infinity here, and this goes to infinity. So maybe this is -2, this is 0, this is 2, this is 4. This is a graph. So the endpoint here is going to look like what? The endpoint here is going to look like a bracket. And I don't know how they do it on the computer. They may have it as a closed-in. It may be like a dot like that. I'm not really sure. But more importantly, x is greater than, so that means that it's going to be, you're going to shade it this direction. This is shaded this direction. And so the interval notation, the endpoint is going to be a bracket, -2, and it's going to go to infinity. And remember, infinity always has a soft bracket, or it always has a soft bracket. So let's look at these three. Let's look at these three notations here: the solution, the graph, and the interval notation. They all say the same thing. They all say the same thing, just they're picturing it different ways. Let's look up here. So you see x is greater than or equal to -2. Right, that's like the algebraic solution. Now, if you look at the graph, you can look at it because you're graphing all the equations, all the numbers that are greater than -2. Go to the right. And if you look at the interval notation, again, this is greater than or equal to, so this needs to be a hard bracket, -2 at the end, and at the right is infinity. Because even if you look at this graph, it's going on and on and on to the right. It goes on and on to the right. So that means that it's going to infinity, and that matches the interval notation. So if you look at this, you should see that they all mean the same. X is greater than 2. The graph is x is greater than -2. And then the interval, you know, -2 begins, but it goes all the way to infinity. So the solution, the graph, and the interval notation say the same thing, they're just represented in different forms. All right, any questions? Any questions? All right, so let's look at number 37. 37 is no big deal, it just has a fraction. So when you have a fraction, what are you going to do with this fraction? It's a question. What do you do to the fraction? But what do you do first? What do you want to do first?
The common denominator.
You multiply.
We multiply.
Huh?
Find the common denominator and multiply.
Right, the common denominator, least common denominator in those two terms, or those three terms is going to be what?
6.
6, very good. So that means that you're going to take each term and multiply by 6. You're going to take 6, multiply by 2/3 x. You're going to take 6 and multiply by 1, greater than 6 times 5x over 6. I just kind of wrote it out since I have a big board here. So 3 We're going to 6 2 times, and 2 times 2, this becomes 4x minus 6 is greater than these two cancel, greater than 5x. Okay, so if this was a linear equation, it's like you got your variables on both sides, and you know your variables have to be on the same side. So, I mean, for me as an instructor, I know that students have less problems when the variable's on the left. That's just what I've seen. It's just, you know, it's not scientific, but I know that students have less problem when the variable's on the left when they're doing this. So let's just switch these right here. So this is going to be 4x minus 5x is greater than 6. All right? Because we have to add 6 to both sides. And we have to subtract 5x from both sides. Any questions here? We're at the end of this class, so I'm hoping that I can do that with relatively ease and not, you know, throw anybody off. Any questions here? Any questions? Okay, so then you combine your like terms here. This becomes negative x is greater than 6. And again, now this variable always has to be positive. So, you know, we're going to divide by -1. So remember, whenever you multiply or divide by a negative number, the direction of the inequality changes.
Changes.
So this is going to be x is less than -6. Okay, so this is the solution. Now, what we want to do is make a graph that matches the solution. How do we make a graph that matches the solution? So when we draw the number line, we want to, okay, this is a negative infinity, and this is infinity over here. So maybe this is, we'll put 0 here. 0 here, this is -3. We'll say this is -6. All right. So x is less than -6. So that means that, I don't know, on the computer, you may, okay. You may see an open circle here. They're either an open circle or parentheses. So more important, x is less than, so that means that it's going to be shaded this direction. Well, this parentheses, maybe like this. So it's going to be shaded to the left here. It's a funky graph, but more importantly, it is a graph. And it should be, okay, so I'm going to just change the direction of the parentheses. Okay, so can you see that this is a graph. X is less than, all the numbers that are less than are going to this direction. So now let's look at the interval notation. So you have the solution, you have the graph. So the interval notation, the left endpoint, because this is going to, so look at the graph here. This to the left here. So this endpoint is going to be soft because this is negative infinity because it's going to the left. And the right endpoint is going to be what? -6. I'm just going to say you guys are not replying. So here you have the solution, you have the graph, and you have the interval notation. And more importantly, if you look at them, you should see that they all represent exactly the same.
Okay.
All right, any questions?
No.
Okay. 1026, let's look at let's look at some of these graphing problems here. Any question here? Let's clear this. Let's look at some of these graphing problems, and they were on graphs. Where are the graphs at? Number 39 through 45. We won't look at all of them, of course, but and this is just graphing stuff. Maybe I'll do this. I'll let you do this. The one thing that, okay, let's look at the 39. And it says on number 39, you have graph. And it's telling you to graph by 3 ways. We're not going to graph by all 3 ways. All right. Let's graph by using the slope and the y-intercept. And the reason why I want to use the slope and the y-intercept is because I think that that's the easiest way that I think that's easier for students. Okay, so we're just going to take 39 and we're going to graph by using the slope and the y-intercept. Okay, we have this linear equation here, 5x minus 3y equals 12. And we're going to graph by using the slope and the y-intercept. So if you need the slope and the y-intercept, then that means that you need to put this equation in this y equals mx plus b form. Remember, m right here was the slope. And this b right here is the y-intercept. Right? So that's how we're going to go. So let's take this equation here and solve it for y. So it can be in the y equals mx plus b form. So you have 5x minus 3y equals 12. We're solving for y. So we have minus 3y equals negative 5x plus 12. Subtracting 5x from both sides. Okay, we have to divide everything by negative 3. So we have y equals 5/3 x minus 4. Right, and the question, hopefully you can get here. And now it's in the slope-intercept form. When it's in the slope-intercept form, and this is the method I encourage everyone to use, when it's in the slope-intercept form, then you can graph it very nicely. Because without plotting in the points, remember, you start with your y-intercept. This is your x-axis, this is your y-axis. You start with your y-intercept, which is what here? -4. You know your graph is going to be positive, so you're going to go down 1, 2, 3, 4. So this point right here is your y-intercept. That's 0, -4. And then from here, we're going to go through and do your rise.
Over the run, yeah.
Over the run, right, very good. So you're going to go up how many times?
5.
1, 2, 3, 4, 5. This is not, but you're going to run 1, 2, 3, and the point goes here. And this is 1, 2, 3, 4, 5, 1, 1, 2, 3, and the point goes here. So remember now, So your graph is gonna look like this. I don't have a straight edge ruler, but I'm doing the best that I can. So this is your graph. And I really recommend this and so this is your slope, because you go up here 5 units, and then you go to the right 3 units. You go up here 5 units, and then you go to the right 3 units. So your slope is 5/3, your rise or your run. So more importantly, that's what your graph looks like. It's a positive graph. And you can be able to identify your y-intercept. All right. And again, now the solutions are all provided. So if you have any specific questions, I don't know. I don't know if you guys want to do it. Today is Thursday, Friday, Saturday. We have the exam on Tuesday. Do y'all want to kind of be on your own? Do you want to have another quick Zoom session for any follow-up questions during the latter part of the week or one day next week? Okay, so we had 10 questions, like 3 persons have disappeared. So
We can, I think we can like have another session of Zoom.
okay, so if you want another session, I'll give it to you. We have the exam on Tuesday. So, and so since the students are here, what day would you like? Today is Thursday, Friday, Saturday, or even Sunday. I'm available on Sunday. And it's suggestions. So you should right now, test 4 is open. So you have today, Friday, and Saturday to do test 4. After this section, I'm going to post the password on Blackboard. Remember, you have to have at least a 70% on the review session in order to take this test. So maybe Sunday or Monday?
Monday's good.
Okay. Monday, you want to go with the same time, like 8:39, or you want to do it in the afternoon? What's good?
What y'all doing on Monday? I'm back. I was gone. I got kicked out for a second.
Okay, well then we are trying to see, students want another Zoom session just for, so when we come in on Monday, that means I'm gonna be answering your questions. I want you to come in and ask me questions. Okay, so that's what Monday's gonna be about. So
In the morning.
okay, in the morning. So you want to do from like let's go. You want to do 9 to 11?
9 to 11.
Yeah, that's cool.
9 to 11 a.m. Okay, that'll be good. And I will be.
Professor,
Yes.
can we like fix another time? Because I'm sure I would be having a class on Monday.
Okay, so what day would you like?
No, because my class ends at 12 on Monday.
Will you record though?
I will record.
Okay.
All right, so I'll do, and if you have any specific questions, if you want to shoot me an email or write them down and scan them in, I'll make sure that I go over those specific questions. So we'll do 9 to 11 on Monday. And again, now when I come in at 11 on Monday, I'm going to be asking your questions. I'm not preparing a lesson or anything like that. So I'm going to be answering your questions. So that means on Monday, you should come in with questions. Okay?
Okay.
All right. Yes.
Where can we find the recordings at?
They're on Blackboard under Zoom, under
Video.
videos.
Yeah.
Video classroom?
Just videos.
This video? Okay.
Videos, and you click on them, and I have if you click on them, then I put the like section 5.1, 5.2. So
Oh,
when
okay.
I post this one, this will be final exam review.
Okay.
Okay.
All right.
All right. So
Professor,
yes.
so have you been able to check the last test workings we sent in?